Alrighty, this is the classic old stopper swing lab. Now, being remote kids, you don't have the, won't be able to do this on your own, so you're missing out on some fun of clunking people on the head with this thing. So what happens is there's kind of a balancing act. You got washers that are spinning, because I'm spinning, they're spinning. But what happens, this string can move back and forth. This radius can get shorter, the radius can get longer. And if I go swing it faster, it tends to go up higher and hits big knots, so I can't go any faster. Or I can go faster, but it's not balanced anymore. If I go too slow, then what happens is the weights pull it shorter and shorter and shorter and shorter. Well, the idea is you're going to find the relationship between the speed of the stopper and something else. Virtually, though. You're going to change in your simulation, you can change the masses, add more masses, take masses off, and see what happens to the speed of the stopper. You can change the length of the radius. By changing the length of the radius, I could just make it so instead of going to the tape right there, I could go a little shorter, maybe pick a different piece of tape and see what happens to the speed at a shorter radius versus a longer radius, but keep the masses the same all the time. Or the other thing is I could keep everything the same but the stopper. I could keep the radius the same, I could keep the mass the same, and I could just change the radius of the stopper and see what happens to the speed of the stopper to still keep everything balanced. Remember, if I go too slow, what happens is the weights go down. I go too fast, the weights go up. I have to have a balancing act to keep my radius the same all the times. So it's your choice. It's your choice whether you want to change the radius and see how that affects the speed of this, or whether you want to change the radius by clicking on this virtually. You click on the tape, or you can click on the washers and change the washers, see what that does to the speed of that. And there's one more. Oh, you can click on the mass of this spinny thing, the stopper, and you can change the mass of the stopper. So you have three options. You can either change the mass of the stopper, change the radius of this thing, or the mass hanging there, and see what happens to your dependent variable, the speed of this. So careful when you're finding speed. It's the distance per time. So how are you going to find the distance? Well, your distance for one turn is the circumference of the circle, which is at 2 pi r. So this radius in meters times 2 pi is the distance it travels in one turn. You might find it tricky or not very precise to measure the time it takes to go around once. Start, stop, that's not very precise. A more precise way is, which is 10 times the precision, is 10 of these things. Go start, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that's the time for 10 of these things to go around. But remember, I went 10 times the distance. Or I could just take a tenth of that total time, which would be the average time for one spin, and take this circumference, the 2 pi r, divided by the time for one, and that would be the speed of this. So remember, your dependent variable is the speed, not the time to go around once, which is the period. The time to go around is called the period, time to do one thing. But you need to find the speed of this thing, not velocity, because it's displacement 0 over one turn. So you find the distance traveled, 2 pi r, divided by the time. That's your dependent variable. Your independent variable is either changing the mass, changing the radius, or the washers.